We already learned what it means to be halfway between a point or to be at the midpoint on a segment. Today we're going to talk about what happens if we don't want to be halfway. What if we want to be somewhere in between at some fractional distance? We're going to start on a number line, and then we're going to take that into two-dimensional on a coordinate graph because understanding how it works on a number line makes it much easier to do on a coordinate system. So we're going to start here. Point J is at 2 on the number line, so we're going to go here and we're going to put a J there. Point M is at 20. So we're going to label our number line, and it says, what is the length of JM? So I just want to know how long it is from J to M. So from J to M is from 20 to 2. And so the length of that segment is 18 units. So then we're going to locate point D. Point D is located halfway between J and M. Well, halfway, it'd be half of 18. Half of 18 is 9. Now, understand this is a common mistake. What a lot of people will want to do is they'll want to say it's at 9. It says where is point D, not how far is it to point D. Point D is 9 units away. 9 units away from J and 9 units away from M. So if I start here at J, J is at 2, so 2 plus 9 is equal to 11. Or it'll be 9 away from 20, but I have to go to the left, which means I need to subtract. 20 minus 9 is also 11. So notice it doesn't matter which direction you go from, that either way you're going to end up at 11. So you would put your point right here. Point D is at 11. Now if you put it at 9, notice it's closer to J than it is to M. That's not halfway. Okay? So point L is located, where is point L if it is 1/3 of the way from J to M? So 1/3 of the way from J to M. Well, we already know that JM is 18. We calculated that earlier. So 1/3 of 18, 1/3 of that distance is 6. That means it is 6 away. Okay, I want it to be 6 away from J. So if I start at J, J is at 2, then I need to go to the right, so I'm going to add 6, which means that point L is going to be at 8. So there is point L. It is at 8. Remember, we're saying where is the location? Where is it? Not how far is it to that location. Okay, point G is located 5/6 of the way from M to J. Again, we know that JM is 18. We want 5/6 of 18. So we would take 5/6 of the total distance 18. Couple of ways that you can handle this. One way, let the calculator do the work for you. 5/6 of 18. You can just type it in straight like that and you find out 5/6 of 18 is 15. It's 15 units away. Okay, and it's 15 units away from M. You got to pay attention to where we want to leave from. 15 units away from M. So 15 away from M, M is here at 20 and it's going to be 15 units away. So it's going to go this way, so we have to go to the left, so we would subtract. So 20 minus 5 is, or minus 15, excuse me, I was thinking ahead, is equal to 5. So it would be at 5. That is where point G is. Now, just so you can see, 1/6 of 18 is 3. So that would be from here, we could break this into 6 equal pieces. So it would be 1, 2, 3, 4, 5, 6. So now we have 6 equal pieces, and I want to be 5 of those 6. So I would be 1, 2, 3, 4, 5. There are 5/6 of the way. So you can break it into the number of pieces that the fraction says to break it in, and then count. that will be easier to do on the two-dimensional. For the one-dimensional, for this number line, it's easier just to figure out where you want to leave from, and then do you want to add or subtract so that you can get there. You can also just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you can also count, where that way you don't have to remember whether you're going to add or subtract. You just leave from where I say to leave from. So that point ended up being at 5. Okay, now we have point S is 2/3 of the way from L to M. Okay, L to M, so L to M is from 8 to 20, so LM is equal to 12. It's from 8 to 20, which is 12 units long. So it is 2/3 of 12. Easiest way to handle it is let the calculator handle it for you. 2/3 of 12. It's not the only way. Obviously, you could do it in your head. You could do 12 divided by 3 is 4, and 4 times 2 is 8. You can do 2 times 12 is 24, and 24 divided by 3 is 8. Either way, it is 8 units away, not at 8. It is 8 units away from L. L was at 8, and it's 8 units away from that spot. So you can count 1, 2, 3, 4, 5, 6, 7, 8. Or you can take the 8, its position, and add the 8 that you want to go 8 units away and find out that point S is at 16. And then lastly, we want to know where point A is. Point A is located 1/6 of the way from D to G. So from D to G, let's look. So DG, we need to know how long that is. DG is 1, 2, 3, 4, 5, 6. So DG is 6 units long. I want to be 1/6 of the way, so 1/6 of 6. 1/6 of 6 is 1 unit away. It's 1 unit away from D. 1 unit away from D, from D to G, right? So I want to go from D to G, and I'm going to go 1 unit away. So I can take 11 and subtract, or I can just count one position, and you would get that A is at 10. I should have marked an A up here. Okay, so that is where they are. Where is the point? Where is the point? Where is the point? Okay, be sure you pay attention to how long is it versus where is it. Now, if we go back here and look on 2 dimensions, it is easiest to do in 2 dimensions if you break it into horizontal and vertical pieces. Now really, it's not that bad. Look, you have a horizontal number line and you have a vertical number line. That's it. Basically, you're just looking at this. It's like 2 of these problems on 1 piece of paper, on 1 grid. So point G is at 10, negative 10, 10. So here is point G, and point P is at 2, negative 6. Oh, I miscounted. Point P should be right there. I was afraid of that. So 1, 2, 3, 4, 5, 6. Okay, so we have G and P, and it says, where is the midpoint M? Now, let me show you some different things. One, we know how to calculate the midpoint. We've already done that. So if we calculate the midpoint, it's x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Be careful when you're typing this on the calculator. It's negative 10 plus 2. If you want to look at it, negative 10 plus 2, enter, then divide by 2. If you do negative 10 plus 2 divided by 2, you're going to get the wrong answer. So don't do it that way. We want that negative 4. So the midpoint is at negative 4, and then 10 plus negative 6 is 4, and 4 divided by 2 is 2. So the midpoint is at 4, 2. Now let me show you something, because I want to go back to something. This is something we already know. So let me draw this in so you can see the line and how it exists. Okay, so one of the things that you can do when you are dealing with a number with a grid, a coordinate plane, and you're doing fractional distance, look at this distance right here. If I go in and I go all the way across and all the way down, and I create this big, giant right triangle, and I count from -10 to +2 is 12. It's 12 units long, right? If we just look at that number line right there, just like we just did on the last page. And then from -10 to -6 is 16. So that is 16. Now, look at this. Half of 12, right? If I'm going to go horizontally halfway, midpoint is halfway. If I'm going to go halfway, then I'm going to go 6. 1, 2, 3, 4, 5, 6. It's right here. And then I'm going to go halfway up, which is 8. Half of 16 is 8. 1, 2, 3, 4, 5, 6, 7, 8. And look, I ended up right there at -4, 2. Okay, that is point G. So you can use the midpoint formula, but you can also count it straight off of the graph. Okay, now Q, where is Q located if it is 3/4 of the way from G to P? Oh, that should be M, not G. Sorry, located that wrong. Where is Q if it is 3/4 of the way from G to P? That means we need to know how long it is. Now, that's the hard way to do this. Do you really want to calculate how far it is? Because here's why. You can't count how much 1 is, much less how far 3/4 is. So knowing the distance from G to P in this particular case doesn't help you. Over here, knowing the distance was easy because it was linear. It was all in a straight line on a number line horizontal. But here, yes, it's linear, but it's at a diagonal. And we can't count on this diagonal. We don't know how far 1, 2, 3 is. We can't do that. So here's the easiest thing to do. Break it into horizontal and vertical number lines. So here's what you're going to do. We're going to take this number line. It's 12, this one right here. We're going to start with this one right here. It is 12 units long. I am going to break it into 4 equal pieces because it says 3/4. So 12 divided by 4 is 3. So I'll go 1, 2, 3, 1, 2, 3, 1, 2, 3. So I just broke that number line into 4 equal pieces. And then I'm going to break this vertical number line into 4 equal pieces. 16 divided by 4 is 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So I've broken it into 4 equal pieces also. Now I want to be 3/4 of the way from G. That means I'm going to start up here at G, and here's what I'm going to do. I'm going to go 1, down 4/3, 2, down 4/3, 3, down 4/3. So I'm going to go 1, 2, 3, and I'm going to go 1, 2, 3, and then I'm going to end up right there. That is where point Q is located, at -1, -2. Now notice, I broke that line. See those stair steps? They look like slopes, right? We use slopes a lot in geometry. They're very useful. And so I broke this diagonal line into 4 equal pieces because I broke the vertical and the horizontal into 4 equal pieces. And that just made it nice and pretty and easy to count then the number of steps. I wanted to go 3 steps out of 4 from G. Now, point E is located at 8, 3. Here's point E right here. And it says, what are the coordinates of point A if it is located 2/3 of the way from P to E? So let's draw in our line P to E. Got this line right here. That's P to E. Now again, you can't count along that diagonal, so let's break it into horizontal and vertical components. Now, I want to break those horizontal and vertical components into thirds because it says thirds, 2/3. So this side is 1, 2, 3, 4, 5, 6. This side is 1, 2, 3, 4, 5, 6, 7, 8, 9. So a third, 1/3 of 6 would be 2. 6 divided by 3 is 2. So I'm going to put a mark every 2. And 1/3 of 9 is 3. So I'm going to put a mark every 3. So I broke this line that was 6 units long into 2 groups of 2, and I broke this one that was 9 units long into groups of 3. Now I want to go 2/3 from P. So what I've got is my little stair steps here, right? My over 2 up 3, over 2 up 3. And I'm going to go 2/3 from P. So from P, I'm going to go 1 stair step. Here's 1 stair step. Here's 2 stair steps. So that point is point A, and it is at 6, 0, over 6, up 0, because it is 2 stair steps when I break it into 3 stair steps. So it is the second stair step of the 3, because I broke it into thirds, because it said 2/3. Then it says point D is located half of the distance from A to M. Half of the distance from A to M. So let's look. We know how to do midpoint, but let me remind you how to do this on a grid. Okay, halfway from A to M. If we break that A to M into our vertical and horizontal components, notice that right here, this side right here, if I break this into this little right triangle, then this side is 2, and this side is 10. That little yellow side is 10. And I want to break it, I want to go halfway. It says halfway. Again, I could calculate. I could take these 2 coordinates. Okay, I could take the coordinate of M, and I could take the coordinate of E, or of A, and I could find the midpoint between these 2 points, because I said halfway. Or half of 2 is 1, so I can go down 1, and half of 10 is 5, so I can go over 1, 2, 3, 4, 5, and I would end up at that point right there, which is at 1, 1. So I broke it into 2 pieces because it said half, and then I went one of the 2 pieces. I broke it into thirds. I broke it into fourths. So you break it into however many pieces it says to break it into, and then you count that many stair steps when you're doing it on this grid. Okay, you're breaking everything into horizontal and vertical components so that you are back to doing it on the number line like you're accustomed to. Okay, fractional distance is just a portion of the distance from one end to the other.